Hello, and welcome to this exploration of your mind. Tonight, we will investigate why your brain sometimes deceives you, creating perceptions that feel real but aren't. We tend to trust our senses completely, assuming that what we see, hear, or feel is accurate. Yet, the brain is not a perfect recorder of reality. It constantly interprets, predicts, and occasionally misinterprets information. One common example is optical illusions. Lines, shapes, and colors can be arranged in ways that trick the visual system. A straight line may appear bent, or two identical colors may look different depending on their surroundings. These illusions are not mistakes. They are shortcuts the brain uses to process complex visual information efficiently. Hallucinations, however, take this a step further. They involve perceiving something that isn't present at all. Even healthy individuals can experience brief hallucinations under fatigue, stress, or sensory deprivation. The brain constantly tries to make sense of incomplete input, filling in gaps with predictions based on prior experience. This predictive function explains why you might hear a voice in silence or notice movement that isn't there. Neuroscientists have identified specific brain regions involved in these processes, including the prefrontal cortex and visual areas. Interestingly, these perceptual errors are not random. They often follow patterns, revealing the underlying mechanisms of cognition. If you're finding this topic interesting, consider supporting the channel by liking this video and subscribing. Your support helps bring more content like this and allows us to explore the brain's mysteries further. Memory is closely linked to perception. What you remember is influenced by your brain's interpretations at the time of experience. Sometimes, memories are reconstructed rather than replayed exactly, which can lead to false recollections. Even small gaps in information can lead the brain to fill in missing details, creating experiences that feel authentic. Illusions and hallucinations are just the visible part of a larger system. The brain is always predicting, modeling, and testing hypotheses about reality. Understanding these processes helps explain why, sometimes, we are convinced of something that isn't there. Even ordinary experiences, like seeing shapes in clouds or hearing patterns in random sounds, are the brain's attempt to find meaning. One fascinating aspect of the brain is its reliance on patterns. From an early age, humans are wired to detect regularities in the environment. This ability allows us to predict outcomes, recognize faces, and even anticipate others' actions. However, pattern recognition can also lead to errors. The brain sometimes sees structure where none exists. For example, pareidolia is the phenomenon of perceiving familiar shapes, like faces, in random objects. You might notice a face in a cloud, a smile on a tree trunk, or an animal in the shadows. These experiences demonstrate how the brain actively seeks meaning, sometimes imposing it on ambiguity. Similarly, auditory illusions occur when the brain interprets sounds in unexpected ways. A classic example is the shepherd tone, where a sequence of tones seems to endlessly ascend or descend. Our perception of motion, depth, and rhythm can all be influenced by subtle cues and prior expectations. Even the experience of time is subjective. The brain estimates duration using context, attention, and memory. Moments of boredom may feel longer, while engaging activities seem to pass quickly. Research shows that the brain sometimes fills in missing time intervals, creating a sense of continuity. Even memory is predictive. Rather than storing exact recordings, the brain reconstructs experiences when recalled. This reconstruction can be influenced by context, suggestion, or recent experiences. That's why eyewitness testimonies are sometimes inaccurate. The brain adapts memories to fit expectations. Moreover, the brain excels at detecting patterns even in randomness. Gambling illusions, like believing a slot machine is due for a win, illustrate this tendency. The mind seeks predictability and often perceives order where none exists. Interestingly, this pattern-seeking behavior has evolutionary advantages. Recognizing potential threats, predicting movement, or learning language, they all rely on it. Even though it occasionally produces errors, these mistakes are byproducts of an otherwise highly efficient system. Another fascinating aspect of the brain is its handling of uncertainty. When sensory information is incomplete or ambiguous, the brain does not pause. It makes predictions, booleans to fill the gaps. These predictions can sometimes create experiences that feel entirely real. A phenomenon known as confirmation bias shows how the brain favors information that matches its expectations. For example, if you expect to hear a word in a noisy conversation, your brain may perceive it even if it wasn't said. Attention also plays a critical role in perception. The brain cannot process every detail simultaneously, so it prioritizes certain stimuli over others. This selective focus can result in missing obvious changes or subtle patterns. In experiments, participants often fail to notice large objects when their attention is directed elsewhere, a phenomenon called inattentional blindness. Similarly, the brain sometimes creates illusory conjunctions, combining features of different objects incorrectly. These effects reveal that perception is an active construction, not a passive recording of reality. Even simple tasks, like identifying a color or recognizing a shape, depend on complex neural calculations. Errors in perception are therefore not random. They emerge from the brain's strategies for efficiency and prediction. Interestingly, dreams provide a natural laboratory for studying these mechanisms. During dreaming, sensory input is limited, yet the brain constructs vivid experiences, often mixing memory, imagination, and expectation. Research suggests that this practice strengthens predictive models, helping the brain make faster and more accurate guesses in waking life. Additionally, the brain's reward system influences perception. Expecting a positive outcome can bias sensory interpretation, making neutral events feel rewarding. Even the perception of risk or threat is shaped by this system, sometimes exaggerating danger. Understanding these subtle influences helps explain why two people can witness the same event but perceive it differently. The brain, constantly balancing prediction, attention, and memory, constructs a personalized version of reality. The brain's predictive nature extends beyond perception into decision-making. Every choice we make, from simple gestures to complex plans, involves forecasting possible outcomes. Sometimes, these forecasts are influenced by prior successes or failures, creating cognitive biases. For example, the gambler's fallacy arises because the brain expects patterns to balance out, even in random events. Similarly, anchoring occurs when an initial reference point affects subsequent judgments. Perception is also shaped by multisensory integration. The brain constantly combines input from sight, hearing, touch, and even smell to form coherent experiences. Sometimes, conflicting signals from different senses can lead to surprising illusions. A classic example is the ventriloquist effect, where visual cues influence auditory perception. Another example is the McGurk effect, where seeing a mouth pronounce one sound changes how we hear it. These effects demonstrate that perception is an active interpretation, not a passive reception. Moreover, attention can drastically alter what we perceive. The brain filters vast amounts of sensory input, prioritizing what it considers relevant. This filtering, it can explain phenomena like change blindness, where obvious alterations go unnoticed. The brain is also capable of generating expectations that influence perception before any sensory input arrives. For instance, labeling an ambiguous shape as threatening can make it appear more menacing. These predictive processes are essential for survival, allowing rapid responses in uncertain situations. Even so, they can lead to systematic errors, like seeing patterns in randomness or overestimating threats. Interestingly, the brain maintains multiple models of reality simultaneously. These internal models compete and cooperate to produce the most plausible interpretation of the world. Such a mechanism explains why illusions can be so convincing. They reflect an internally consistent prediction. Even expectations shaped by culture, experience, or education can modify perception. In other words, reality is not just what exists outside us. It is a combination of sensory data, memory, and prediction. The brain's handling of uncertainty is remarkable. When information is incomplete, it generates hypotheses about what might be happening. These hypotheses are continuously tested against incoming sensory data. If the data matches expectations, the brain reinforces the model. If not, it adapts. This constant prediction and correction loop underlies much of our cognition. Even something as simple as reading can involve dozens of predictions per second. Your mind anticipates upcoming words, punctuation, and context to comprehend efficiently. Errors in these predictions are often subtle and unnoticed, yet occasionally they can produce striking effects. One striking phenomenon is the brain's response to ambiguous stimuli. When shown a vague image, people often interpret it based on prior knowledge or expectations. This explains why different individuals may see entirely different things in the same stimulus. Similarly, ambiguous sounds can be perceived differently depending on context. For instance, a tone sequence may be heard as rising by one listener and falling by another. Learning and adaptation also play crucial roles in perception. Repeated exposure to certain patterns tunes the brain to recognize them more efficiently. This is why musicians, athletes, or experts in any field perceive details that novices miss. Yet, over-specialization can create blind spots. The brain may ignore unexpected stimuli that don't fit learned patterns, even if they are important. Another aspect is the integration of conscious and unconscious processes. Much of perception occurs below the level of awareness, shaping how we respond to the world. Subtle cues, like body language or tone of voice, are often processed unconsciously, yet influence judgments. Even memory consolidation during sleep relies on unconscious processing. Interestingly, the brain can create false confidence in its predictions, making errors feel inevitable. Optical illusions, auditory tricks, and misremembered events are all consequences of this sophisticated system. Everyday judgments, like estimating distances or speeds, rely on these predictive computations. Understanding these mechanisms helps us appreciate both the brain's power and its limitations. Humans are inherently social creatures, and the brain has specialized systems for interpreting others. Mirror neurons, for example, activate both when performing an action and when observing it in others. This mechanism allows us to predict intentions, mimic behaviors, and empathize. Yet, these same systems can produce errors, such as misreading facial expressions or tone. Emotional biases heavily influence perception. A person in a fearful state may interpret neutral stimuli as threatening. Similarly, positive emotions can lead to overestimating benefits or opportunities. For instance, the brain sometimes favors short-term rewards over long-term benefits, a bias known as temporal discounting. Creative thinking also exploits the brain's predictive nature. By recombining familiar elements in new ways, the brain can generate novel ideas. Sometimes, this results in surprising insights. Other times, in improbable or impossible scenarios. Interestingly, even errors in prediction can lead to innovation. Scientists have documented that accidental misperceptions or faulty assumptions sometimes spark discoveries. The brain operates in parallel, processing multiple streams of information simultaneously. This parallelism enhances speed and efficiency, but can also create conflicts between competing interpretations. For example, the visual and auditory systems may provide contradictory cues, leading to perceptual ambiguity. The brain resolves these conflicts by weighing probabilities based on experience and context. Even when the resolution is incorrect, it often feels internally consistent and convincing. This internal consistency explains why illusions and false memories are so compelling. Moreover, the brain's wiring allows for subtle crosstalk between emotion, memory, and perception. A single event can evoke complex, overlapping responses, blending factual recall with emotional coloring. Understanding this interplay clarifies why human experience is rarely purely objective. Even subtle shifts in context, expectation, or mood can drastically alter perception. Memory is not a perfect record of events. it is reconstructive. When recalling an experience, the brain pieces together fragments of perception, emotion, and prior knowledge. This reconstruction can introduce errors without our awareness. False memories are a striking example. People may vividly recall events that never occurred. Even confidence in these memories does not guarantee their accuracy. Research shows that suggestion, repetition, and emotional context can all shape memory. The brain actively integrates beliefs with incoming information, sometimes altering perception to fit expectations. This mechanism underlies phenomena such as confirmation bias and motivated reasoning. Even seemingly objective judgments can be subtly biased by prior beliefs. Another fascinating area is inattentional neglect. The brain often fails to notice unexpected stimuli when attention is occupied, even if they are prominent. This effect has real-world consequences, from traffic accidents to missed social cues. Even short-term distractions can lead to permanent gaps in what is perceived. The brain also employs predictive coding, constantly generating expectations about incoming data. When reality deviates from prediction, we experience surprise, curiosity, or confusion. This mechanism is adaptive, enabling rapid responses and learning from discrepancies. Yet, predictive coding can also generate illusions and hallucinations when the brain over-relies on expectation. Even mundane experiences, like interpreting a casual gesture, depend on these predictive processes. Furthermore, the brain often fills gaps with plausible information rather than admitting uncertainty. This tendency explains why urban legends, myths, and conspiracies can feel believable. Social reinforcement amplifies these effects, as shared beliefs validate personal perception. Even subtle cues in media or conversation can bias memory and perception, sometimes without conscious awareness. Understanding these processes provides insight into how human perception is a mix of reality, expectation, and interpretation. The brain's interpretation of risk is deeply influenced by emotion. A situation that is objectively safe can feel threatening if fear or anxiety is present. Conversely, a dangerous scenario may seem harmless under excitement or euphoria. These distortions highlight the brain's prioritization of survival over accuracy. Even small biases in perceived risk can influence major decisions. Humans often overestimate rare dangers and underestimate common ones, a phenomenon known as probability neglect. These tendencies can explain why people fear flying more than driving, despite statistics. Beneath conscious thought, the brain continuously makes predictions using prior experience. These unconscious predictions shape perceptions before awareness occurs. For example, a subtle shift in posture or facial expression can signal intention or emotion. The brain often anticipates these cues, preparing responses in advance. Mistakes arise when the predictions do not match reality. These mismatches can lead to false assumptions about others' intentions or environmental hazards. Emotional reasoning also interacts with logic, sometimes overriding rational thought. A single strong feeling, like anger or desire, can bias judgments and memories. Moreover, the brain is constantly predicting the outcomes of social interactions. These predictions help navigate relationships, but can also generate misunderstandings. Even minor inconsistencies in tone or gesture may be misinterpreted due to predictive assumptions. Interestingly, creativity leverages these prediction errors. By exploring unlikely connections or imagining alternative scenarios, the brain generates innovation. Paradoxically, the very errors that mislead us can also be the source of insight. Understanding these mechanisms clarifies why human perception is simultaneously powerful and fallible. Even when the brain misleads us, it is operating according to deeply adaptive principles. The brain's sense of time is another domain filled with distortions that occur outside conscious control. Moments filled with intense focus and can feel shorter, while uneventful intervals seem to stretch endlessly. This variation arises from how the brain encodes experiences rather than from time itself. When the brain processes more information, it creates denser memories, giving the illusion of speed. In contrast, monotony generates sparse memory traces, making intervals feel long in hindsight. This explains why childhood summers felt endless, while adulthood weeks pass unnoticed. Another subtle distortion occurs in the brain's handling of coincidences. Humans tend to perceive patterns even when events are unrelated, a consequence of pattern-seeking wiring. This propensity increases the likelihood of inferring meaning where none exists. Coincidence detection was useful for early humans navigating uncertain environments. However, in modern settings, it can generate false assumptions about causation. Small correlations may be interpreted as intentions, signs, or predictions. The brain's relationship with memory also introduces significant distortion. Memories are not stored as exact replicas, but as reconstructed impressions. Each recall subtly rewrites the original, blending past and present interpretations. This process can lead to confidence in memories that are partially inaccurate. Emotion further shapes how memories are stored and retrieved. Events tied to strong emotion create durable but sometimes exaggerated recollections. Meanwhile, neutral details fade quickly, giving the illusion that they were never present. The brain also compresses information to conserve cognitive resources. This compression omits fine details and keeps only what appears relevant. As a result, memory becomes a blend of fact, inference, and assumption. Another overlooked mechanism is sensory prioritization. The brain continuously filters incoming stimuli, selecting only those deemed important. This filtering prevents overload, but ensures many sensations never reach awareness. It also means two people can share an experience, yet perceive it differently. Differences in attention, emotion, and expectation create unique subjective realities. Through these mechanisms, the brain constructs not just perception, but the very narrative of lived experience. The brain's relationship with language introduces another layer of subtle distortion. Language is not merely a communication tool, it shapes how the mind categorizes reality. Different languages divide the world into distinct conceptual boundaries. A language with multiple words for a single idea encourages finer discrimination of that concept. Meanwhile, languages with fewer distinctions can cause broader, less precise categorization. These linguistic structures quietly influence reasoning and perception. Even memories can be shaped by the words available to describe them. The brain often retrofits experiences into linguistic patterns, simplifying complex sensations. This transformation omits nuances that cannot be easily expressed. Another area where the brain introduces systematic bias is in decision-making under uncertainty. To compensate for incomplete information, the mind relies on heuristics, mental shortcuts that save time. These shortcuts often work, but they can also produce predictable errors. One example is anchoring, where early information disproportionately influences later judgment. Once an anchor is set, the brain gravitates toward it even when new evidence contradicts it. Similarly, confirmation bias leads the mind to favor information that supports existing beliefs. Conflicting data is minimized or dismissed, often without conscious awareness. These biases help the brain maintain coherence but reduce objectivity. On a neural level, the brain's reward system strongly affects perception. Stimuli associated with reward gain priority and attention. This selective enhancement evolved to promote survival, directing focus toward beneficial outcomes. However, in modern environments, it can distort value assessment. Activities that trigger frequent small rewards can overwhelm rational decision-making. This is why habits form easily around pleasurable actions, even when they offer little long-term benefit. Another subtle distortion arises from cognitive load. When the brain is processing too much information, perception becomes narrower and more selective. Details outside the focus area may be entirely overlooked. This explains why multitasking often leads to errors and fragmented understanding. Through these mechanisms, the brain constantly shapes and reshapes subjective reality. The brain is constantly balancing precision and efficiency in perception. This balance can create systematic illusions that feel perfectly real. For instance, motion illusions occur when static images are interpreted as moving. Certain patterns, like repeating stripes or contrasting colors, can trick the visual system. Similarly, tactile illusions reveal the brain's assumptions about touch. One example is the phantom limb phenomenon, where amputees feel sensations in missing limbs. Even pain can be mislocalized due to neural wiring and expectation. The brain also actively corrects perceived errors when attention is applied. This conscious error correction is crucial for learning and skill refinement. For example, when learning a musical instrument, initial mistakes are detected and gradually adjusted. Similarly, athletes rely on real-time feedback to refine movements and anticipate opponents. Attention is a limited resource, and the brain prioritizes some stimuli over others. Distractions can prevent error correction, leading to persistent misperceptions. Even brief interruptions can alter how events are encoded into memory. The interplay between focused attention and distraction explains why eyewitness accounts are often inconsistent. Perception is also shaped by statistical learning. The brain unconsciously tracks regularities in the environment to anticipate future events. This learning influences everything from language comprehension to detecting subtle visual cues. Interestingly, when expectations fail, the brain experiences a prediction error, signaling a need to update models. Prediction errors are central to adaptation, learning, and creative problem solving. Even simple visual tasks, like identifying a moving object in a cluttered environment, rely on constant prediction and adjustment. Understanding these mechanisms reveals why perception is both astonishingly accurate and surprisingly fallible. This tendency is closely tied to your mind's drive for efficiency. Instead of waiting for perfect clarity, it fills informational gaps by drawing on previous experiences, learned patterns, and unconscious assumptions. This rapid completion process often serves you well, allowing you to react quickly in daily situations. Yet, the very mechanism that provides speed also introduces countless opportunities for error. Errors subtle enough that you rarely notice them happening. Another intriguing component involves the way your brain prefers coherence over accuracy. When faced with conflicting pieces of information, it tends to weave them into a single, stable narrative, even if doing so requires ignoring certain details. This internal storytelling ability helps preserve psychological stability, but it also means your perception of reality is constantly being edited in small but meaningful ways. Consider also how strongly context shapes interpretation. A phrase spoken in a calm environment can feel reassuring, yet the same phrase delivered in a tense moment may be perceived as unsettling. Your brain evaluates not just the information itself, but the surrounding emotional and physical cues. Without realizing it, you rely on these contextual signals far more than the literal content of what you perceive. All of these phenomena, gap-filling, coherence-seeking, context-shaping, contribute to the subtle ways your brain bends reality. Not to deceive you deliberately, but to keep your internal world running smoothly with limited resources. Understanding these mechanisms does not eliminate them, yet it gives you a clearer grasp of why your mind often behaves in unexpected ways. And with that, we come to the end of this long story about the mind's hidden shortcuts. Thank you for spending this time exploring these ideas. If you found this journey meaningful, you are welcome to return anytime for another deep dive into the workings of the mind.